Okay, welcome everyone. Let me just test the screen and the audio and make sure it's working properly. Okay, nice. It's working properly. I will start in exactly maybe 2 minutes time. So I'll wait for a little bit more so that more people can come in as well. Then we'll start. I can see some of the comments already. It's, XOYT, Sushi Games, and then Shanghai Post says hi. Okay, hi to you all too. Hey, some of you saying you're not very confident. Well, we'll find out whether your guess is correct or not once we go through the paper. Hi to Jennifer as well. Okay, let's start. I think it's a good time to start. Okay, I will be speeding through the first 10 questions because these 10 questions are pretty easy. Yeah? So question number one says that evaluate the following number. So here, if you follow the order of operations, 2 times 5 is equals to 10. So on the left hand side, we have 20 plus 10 plus 2, that's equals to 32. I want to divide by 40 plus 8 minus 3. Right. That's going to be what? That's, actually, no. Wait, this is a typo, actually. Sorry. This is supposed to be a divide over here. Sorry about that. This is a divide. So then what we have is 40 divided by 8 is 5. Right. 5 minus 3 is equals to 2. So actually what we are doing is 32 divided by 2, which is equals to 16 in the stance. Uh, Hi Paul, can you try to not send so many messages? Thank you. Let's move on to the next question. Question number two. Question number two. What you have is the shape on the left is to this thing as the new shape is to what? The idea behind this question is initially you might think, oh, I'm just splitting this thing into two separate diagrams, right? But if you look through the answer options, there's no option in which you split this into two separate diagrams. So what's going on then? Well, the idea that's going on here is that you're actually pushing two triangles together. You're pushing this blue triangle and this red triangle together, right? So that in the end, when you have the two blue triangles, this is the one that's blue color, and then this is the one that is red color. You're pushing them together. So in a similar way, you try to push them together for the diagram on the right. So if you push these together, you can see that the circles, they will overlap. You have the vertical line from the first circle, and of course, you have the X shape from the second circle as well. So therefore, the answer is the option 102. Okay, let's move on to question number three. Question number three, we have Adam, Ben, and Clarence, right? ABC, they shared some candies. The number of candies that each boy has is in the ratio 3 to 7 to 9 respectively. And the average number each has is 38. So let's say I call them 3 unit, 7 unit, and 9 unit. In that case, what would be the average? In that case, the average will be equals to 3 units plus 7 units plus 9 units divided by 3, right? Because there are 3 people. And this is equals to 38. So what does that tell us? Well, 3 plus 7 plus 9 is 19. So 19 unit is equals to 38 times 3. Now we can divide by 19. So 1 unit is equals to 38 divided by 19, that's 2 times 3, that's equals to 6. So therefore, Ben, the one with 7 units, will have exactly 7 times 6 equals to 42 candies. And that is the answer. Okay, let's move on to the next question. Question number 4. Sarah cycled from her home to the park at an average speed of 12 km per hour. If her average speed for the entire trip going to the park and back without stopping was 16 km per hour, what was her average speed on the way back? Now, you might be tempted to think, hey, the answer would then be 20, right? Because the average of 12 and 16 is equals to 20. But is that correct? Well, the way we can understand average speed is total distance divided by total time. So let me write it down. Okay, here what we can do is that we can set some kind of convenient distance here. Now, if I set a convenient distance, I'll try to look for a multiple of 12 and 16. I notice that 48 is a multiple of 12 and 16. So let's say that the entire journey is going to be 48 km one way. Yeah? There is also going to be 48 km on the way back. For example, on the way there, how long does Sarah spend? Sarah spends 48 divided by 12. That's 4. Sarah spends 4 hours on the way there. What about the time for the total journey? Well, Sarah cycled 96 km for the total journey. So we can do 96 divided by 16. That's equals to 6. So that means these two parts combined together is actually going to be 6 hours. So therefore, the part that is returned will be 2 hours. And so actually, the average speed on the way back will be then 48 km divided by 2 hours. That will be equals to 24 km per hour. And that will be the correct answer, right? Instead of 20 km per hour. So this is a common trick you need to take note of. Huh? Okay, let's move on to question number 5. Question number 5, it is known that the whole number in each box below is the same. What is the whole number? Well, if each is the same, let me just call this box the letter A. So each of them I'll replace with the letter A. What will be the expression here? A plus A is equals to 2A. A minus A is equals to 0. A times A, we can write it as A squared. You can also write it as A times A, no problem. And finally, A divided by A is equals to what? So we have something that is A times A plus 2A plus 1 equals to 2025. Here we can use a little bit of guess and check. So for example, we need a number close to 2000, right? One number times itself is close to 2000. Well, 40 times 40 is pretty close to 2000, right? So you can try A equals to 40, you'll get 1600 plus 80 plus 1. That's 1681. It's not quite close enough. So when we continue our guess and check, we see that if we try A equals to 45, then what you have is 45 squared is 2025 plus 90 plus 1. That's too big. So what number do we try? Well, I see a lot of you actually have sent me the correct answer in the chat already. The answer is A equals 44. When you try A to be 44, you will get 1936 plus 88 plus 1, and that is 2025. That is the correct answer. So the answer is 44. Okay, let's move on to question number 6. The question number 6, what we have is a bar graph. The following diagram shows the number of apartments sold by a real estate company each month last year. So across January, February, and March, a total of 84 apartments were sold. What's the total sold in October, November, and December? Let's take a look at the graphs. If I call this level 1 unit, then what we can see is that January will be 4 units, February will be 5 units, and March will be 3 units. So then we notice that 12 units is equals to 84, and then I can divide by 12 to get 1 unit is 7. Now let's take a look at October, November, and December. October, this level here, if you draw all the way to the left, is this point, which is actually 8 units. And then same thing for December, that will be 8 units. And for November, it will be 6 units. So together, across these 3 months, it will be 8 plus 8 plus 6, which is 22 units. That will be equals to 22 times 7, 154. Okay, question number 7. Which of the following is the odd one out? I believe that this question most of you should have figured out. The answer is the last option, 205. Now, why is this the last option? The reason is because the last option, the 4 parts are not equal to each other. They are not the same parts. Right? For example, on the left, we have all of them are squares. For the 202, all of them are this particular shape, right? All of them are the same shape. For 203, all of them are the triangle. For 204, all of them are the rectangle. But for 205, we can see that these two parts, they are actually not the same. Right? So therefore, the answer is this 205. Okay. One of you say not the same area. Yeah, not the same area is also correct. Okay, question number 8. We have Amina has some buttons, while Benjamin, Chenwei, Deepa, and Ethan had none initially. So these are A, B, C, D, E. She gave half of her buttons to Benjamin. Then Benjamin passed a third of the buttons he received to Chenwei, and then later gave a quarter of his remaining buttons to Deepa. Meanwhile, Amina gave a fifth of the buttons she had left to Ethan. What's the minimum number of buttons that Amina has now? So let's try to figure out. So what we're going to do is that we're going to say that Amina at the start had 1 unit. Okay. So what would she do? She would pass half to Benjamin. So Benjamin will be at half units. Now Benjamin then passed 1/3 of the buttons he received to Chen Wei. So 1/3 of half is equals to 1/6. This will go to Chen Wei. And then later, a quarter of his remaining buttons to Deepak. Here, there's something to take note. Is a quarter of his remaining buttons. So at this point, how much does Benjamin have? Well, Benjamin will have half units minus 1/6 units, which is 1/3 of a unit. So a quarter of 1/3 of a unit is equals to what? A quarter of 1/3 unit is equals to 1/12 units. This will be given to D. Okay, and at the same time, Amina also gave 1/5 of the buttons she had left to Ethan. Alright, so again, is the remaining buttons. So how much does Amina have at this point? Well, half units. She gives 1/5, so this one will be equals to 1/2 times 1/5, 1/10 units. Now, we're trying to determine just from these conditions what's the minimum number of buttons. It seems like there is not enough conditions. But the trick is that everyone must have received a whole number. Right? You cannot receive half a button. That is not possible. So if it is a whole number, then what you can see is that it must be a multiple of 2, 6, 10, and 12. In that case, what is the smallest multiple of 2, 6, 10, and 12? Well, we can see that that will be equals to 60. This is the smallest uh, multiple, also called the lowest common multiple. So the 1 unit is equals to 60, but that is not the answer because they're asking for how much Amina has now. Amina has exactly half units from the part that's left over from giving to Benjamin, and then times 4 over 5, which is the part left over after giving to Ethan. So this is equals to 4 over 10 times 1 unit of 60, 24. Okay, let's continue on. Question number 9. Question number 9, what we have is the figure shows a square ABCD with a side length of 10 cm. We have F is a point AB and E is the midpoint of the F. So midpoint means it lies directly in the middle. Find the sum of areas of triangle ADE and triangle BEF. For this question, we need to know a certain fact about areas, which is that if you're given a triangle, you cut at the middle, at the midpoint here, then these two things will have equal areas. So the way we can understand that is that we can see that firstly, these two have equal areas that I'm going to both call the letter X. Right, they have equal areas because E is the midpoint on FD. But then we can also label something else. If I connect BD, then I can label both of these with the letter Y. Again, same reason, it's because of the fact that E is the midpoint of FD. Okay, I see some of you are making a lot of comments in the chat. Maybe you all can keep these comments to yourself first, right? Let's just discuss about the math, if that's fine with you. Okay, so now what we can see is that the shaded area is X plus Y, and X plus Y is going to be what? Is going to be equals to half the area of the triangle ABD, right? Because triangle ABD has two copies of X and two copies of Y, right? So it's twice of the shaded area. But then what's the area of triangle ABD? Well, we know that triangle ABD is equals to half the square. So it will be equals to half times 10 times 10. So this is equals to, in the end, 25. That's the answer. Okay, let's move on to question number 10. Question number 10. A school lecture theatre has 10 rows of seats, and then there are different seats in each row, as you can see, right? Some rows have 10, some rows have 11, 12, 14, and 15. Now we seat K students in the lecture theatre, and no two rows contain the same number of students. What is the largest possible value of K? So I want to put as many students in as possible. Let's put 15 all in row J. Then what can we do next? We can put 14 in row I. Then we can see that there are 3 rows with 12. So there's no 13. So the next largest I can put in is the number 12. Then we notice that the next largest number I can put in is 11, right? Because no two rows must have the same number. So the next largest I can put in is 11. I can put 11 here, I can put 11 here, I can put 11 here. It's all the same thing. It doesn't matter. So let's put 11 here. The next largest I can put is 10. The next largest I can put is 9, 8, 7, 6, 5. So this will be the largest number of people that you can put in the lecture theatre so that no two rows are the same. In that case, what's the number of students? Well, the sum is equals to 19 plus 19 plus 19 plus 20 plus 20. So that's going to be equals to 97. That is the answer. Okay, with that, we've finished the first 10 questions, which are the 1-mark questions. Now, let's move on to the 2-mark questions, which are going to be a little bit harder. So I'll slow down a little bit when I'm talking about these questions. 11 says that the sum of 3 numbers is 94. if the ratio of the first number to the second number is 1 to 3, and second number to the number is 5 to 9, what is the second number? So let's write it down. 1 to 3, 5 to 9. The way you make the ratio comparable between all three is to make the middle number the same. In that case, I will choose 3 times 5 equals to 15. 5 to 9 is the same thing as 15 to 27. And then 1 to 3, I can multiply this by 5, is the same thing as 5 to 15. So the numbers are 5 to 15 to 27, right? Let's say it's 5 units, 15 units, and 27 units. Then the sum here will be how many units? 5 plus 15 plus 27, that's equals to 47 units. So therefore, this is the 94. And then we can figure out that 1 unit is equals to 2. And from here, we can figure out that the second number for this question is just equals to 30. Right? And that is the answer. Okay, let's move on to question number 12. There are 1,000 apples and oranges in the supermarket warehouse. When more apples and oranges were added, the number of oranges increased by 20% and the number of apples increased by 50%. Given there were 120 more oranges than apples in the end, how many apples were added to the warehouse? Okay, so what do we do? Well, we try to set up equations. At the start, apples plus oranges. I'm going to have 1,000. Now, I'm not going to write down the letter O for oranges because of the fact that O looks like the looks like the number 0. So instead, I'm going to write down B for oranges. Okay, I'm going to write down B. So this is apples and oranges. At the start is 1,000. When more apples were added, apples increased by 50%, right? So 50% becomes how much? That's 1.5 of A. Oranges increased by 20%, so this B will increase by 20% to become 1.2B. But this time it is not addition, is it? It is not addition, it is 120 more oranges than apples. So therefore, we need to use the apples, subtract off the new oranges, we can get 120. And from here, I want to find out basically what's A and B. One way we can do this is try to remove the letter A. To do that, we can multiply the first one by 3, multiply the second one by 2, and then add them together. Because we get 3A plus 3B is equals to 3,000. Okay, and then for the second one, if I multiply by 2, then what I have is 2.4B minus 3A is equals to 240. And then we can add them up to remove the letter A. When we add them up, we can see that the 3A and the minus 3A will disappear. The 3B and the 2.4B will add up to become 5.4B. That's equals to 3,240. So to find B, what do we do? To find B, we just do 3240 divided by 5.4. Now we can say the same thing if I do 32400 divided by 54. It's the same division as 3240 divided by 5.4. So here we realize that exactly 6 times of 54 will give you the 324. So actually this is exactly 600. Okay, so we know that B is equals to 600. So A will be equals to 400. How many apples were added? Since apples increased by 50%, the number of apples added is exactly equals to 200. Okay, let's move on. Question number 13. In triangle ABC shown below, DE and F are points on AB, BC, and AC respectively. We have BD is equals to 3 times of DA, so this is a 3:1 ratio. At the bottom, BE is equals to EC, so this is a 1:1 ratio. And on the right side, AF is 2 times of FC, so that's a 2:1 ratio. So they're given that the area of the triangle ABC is 96, find the area of the shaded quadrilateral ADEF. We can divide this diagram along the diagonal AE. So I split it into two parts. Now on the left side, what happens? On the left side, we basically have half of the triangle, right? And that's being cut into the ratio 3:1. So half of this triangle is 48. 48 cut in the ratio of 3:1. What's the value? The value is going to be 36 and 12, right? So I can write down the 36 and 12 here on the left. On the right side, what do I have? On the right side, we have something similar. On the right side, we have half of the triangle as well. And this half of the triangle is going to be cut in the ratio of 2:1. So if you split 48 in the ratio of 2:1, what's going to happen? 48 in the ratio of 2:1 is going to be equals to 32 and 16. So this 32, this 16. The answer is 12 plus 32, 44. Okay, let's move on to question number 14. Question number 14. You want to have a whole number satisfying all of the following conditions. Divide by 8 is remainder 1. Divide by 5 is remainder 2. Divide by 6 is remainder 3. What is the largest such number? Less than 2025. Now, we can try to combine the conditions together. You can actually try to combine any two conditions together at first. Now, to me, I want to leave the middle one for the last one. Because it is very easy to see what numbers divide by 5 have remainder 2, right? They must end in 2 or 7, basically. So let's start with the first and last one. First and last one, let's list them out. Divide by 8, remainder 1, what are those? 1, 9, 17, 25, dot, dot, dot. Divide, divide by 6, remainder 3, 3, 3 plus 6, 9, 9 plus 6, 15, dot, dot, dot. And hey, you can already see there's one of them in common. So together, what this means is that actually I'm going to divide by 24 remainder 9. Why 24? Because 24 is the common multiple of 6 and 8. That is the lowest common multiple. If you say divide by 48 remainder 9, then you'll be wrong. Because although 48 is 6 times 8, 48 is not the lowest common multiple of 6 and 8. Now, obviously, this number will be odd, right? Because it's a odd remainder when divided by 24. So if it's an odd number, we know that it must end in 7. The reason why it must end in 7 is because the middle one, you can say that, okay, it's end in 2 or 7 for the units digit. Those are the only ones with a remainder of 2. So we're looking for a number that divided by 24, remainder 9, ends in 7. What is that? So 9, 9 plus 24, 33. 33 plus 24, 57. There we go. 57 ends in a 7, right? Okay, so this is under divide by 24 and divide by 5. So together, what we conclude from here is actually divide by 120, remainder 57. 120 comes from 5 times 24. Right, it's the lowest common multiple. So then we can go try to find the number. So we know that one such number that will be a multiple of 120, a close multiple of that to 2000 is 1800. Right? 1800 is a multiple of 120. So in fact, 1857 is one of them. Let's add another 120, that's 1977. If I add another 120, it's going to be 2097. That's too big. Right? Don't want to have this. So therefore, the largest number that divide by 120 has remainder 57 will be the number 1977. Okay, let's move on to the next question. Question 15. Tom sits for a series of tests. In his second last test, he scores 89, which increases his average score from 78 to 79. If Tom aims to achieve average score of 80, what is the score he must obtain in the last test? So we don't really know how many tests he does. But I know that before his second last test, he has a score of average 78. So what we can do is that we can use a little bit of algebra. So let's say that before the second last test, let's say before second last test, there are n tests. Then the score so far is 78 times n, right? Because that was the average. Now then what happens is that when he scores the 89, the average increases from 78 to 79. So this number plus the 89 increases the average. Increases the average to 79 now. And there are now n plus 1 tests. Right? There are n plus 1 tests, and then the average is 79. So what does this mean? Well, this means that 78n plus 89 is 79n plus 79. So if I cancel out 78n and 79n, that's 1n is 89 minus 79, which is 10. So there are 10 tests before the second last test. Now I want to raise the average to a score of 80. So what does that mean? Currently, the number is 79 times 11. I want to add some number here so that the result can be 80 as the average. 80 times how many? 80 times 12, right? Because there will be 12 tests at this point. So let's go and calculate. 80 times 12 is equals to 960. 79 times 11 is going to be equals to 79, and then 79 here. That's 869. So what number do you need to add? You need to add the number 91. 869 plus 91 will give you 960. Okay, let's move on to question number 16. Each square here is to be filled with a different prime number chosen from the first 10 prime numbers. Right, 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Out of these 10 numbers, I'll use 7 of them in the numerator and add them up. I'll use 3 of them in the denominator and add them up. And then I want to make the expression an integer. So that means I want to make the numerator a multiple of the denominator, right? What's the maximum possible value of x? The trick for this question is that when we look at the numerator and denominator, we know what the sum is. We know the sum of the numerator and denominator because it's just a sum of all 10 of the prime numbers. So let's try to add up all 10 prime numbers. Huh? Okay. This is equals to 30, this is equals to 30, this is equals to 30, right? This is equals to 10. So we have 100. 100 plus 29 is equals to 129. So the sum here is 129, and then we want to make sure that the denominator is a factor of the numerator. So what can we do? Well, 129 is equals to 3 times 43, where 43 is a prime number. Okay. So firstly, one idea that we can have is maybe we can make it as 128 over 1. This is going to be a whole number. But of course, it's impossible for the denominator just equals to 1. What else can you do? Well, you're looking for the next factor, 3. So 3 can also work. This will be 126 over 3. It's still going to be a whole number. But again, 3 is too small for the denominator. The next possible choice will be equals to 86 over 43. This will also add up to 1293. Now this seems to be possible, right? Is this possible? You can see that if I let the denominator be 2 plus some numbers add up to oh sorry, no, not 2. I made a mistake here. Yes, I do 3 plus 17 plus 23. Then this is an example that will add up to 43, isn't it? And then the remaining whatever's on top will obviously just add up to 86 on their own. So this is in fact possible. So in that case, the maximum possible value of x is actually pretty small. This is just equals to 2, right? So therefore, the maximum possible value of this question, the answer is just going to be equals to 2. Okay, question number 17. Question 17 says that 25% of A's money is equals to 40% of B's money. Okay, so we know how to compare that, right? We know that 25 over 100 of A equals to 40 over 100 of B. In other words, 25A equals to 40B or 5A equals to 8B. Here, I can write down as a ratio of 8 to 5, right? The ratio is the opposite of this 5 and 8 given here. For the second condition, 30% of A's money is equals to 40% of B plus C. So what can we do? Just like what we did on the left side, we can multiply by 100 to get rid of the denominator. And then here I can divide by 10, 3A equals to 4B plus 4C. So if I call A, let's say 8 units, B, let's say 5 units, then what we have here is this is 24 units. And then 4B will be equals to 20 units. So what's C? Well, that means that 4 units is 4C, so C must actually be 1 unit. Finally, the last condition, A has $210 more than C. That's going to be 7 units, is $210. So therefore, B 5 unit will be equals to $150. That is the answer for this question. Okay, question number 18. The figure shows a trapezium ABCD with AD parallel to BC. The points E and F are the midpoints of AB and DC respectively. We have the base is equals to 30 and the perimeter is equals to 62. Find the perimeter of trapezium ABCD. So the 62 is what? Is equals to BCFE, right? Now, the way we can do this question is that we can label the same parts with the same letter. E on the left-hand side is the midpoint, so let's label both of these as X. Y on the right side is the midpoint, let's label, F on the right side is the midpoint, so let's label both of these as Y. Now, one other thing we can tell from this diagram is that the line EF, it is actually going to be the average of AD and BC. Why is EF the average of AD and BC? So this is a fact that's generally true for trapeziums. For trapeziums, what do we know is that if I, okay, let me draw it a bit better. Just give me a while. Okay, wait, I cannot connect this line. Okay, never mind. So what we can do to this trapezium is that I can actually make a copy of it and then flip it around. Okay, and I'll put the two trapeziums together. So what kind of shape do you get when you put two trapeziums together like this? You get a parallelogram. And now if you take a look at the one connecting the midpoints here, you can see that this horizontal length is the same as the top and the bottom, right? For your parallelogram. So therefore, what you can see is that if I just take half of it, if I just take this little part, on the left, it will then be the average of the top and the bottom. Huh? Okay, back to the question. How does EF being the average of AD and BC affects us? So we can actually use another variable if you want. It looks a bit scary, but in the end, trust me, all these variables will disappear. If I call this Z, then EF is half times of 30 plus Z. Okay, so now the condition of 62 is equals to what? Is 30 plus X plus Y plus half of 30 plus Z is 62. Okay, one of you mentioned that's bottom times top. I'm not quite sure what you mean. Bottom times top. It should be the average, right? So it's 30 plus Z divided by 2, right? It looks correct to me. Okay, so now what we can do is that we can remove the 30, we can remove the half times 30, that's 45 you can remove here. So X plus Y plus half Z is equals to 17. And now to find the parameter of the trapezium ABCD, what is that? That's the bottom 30 plus the left hand side, that's 2X, plus the right hand side, that's 2Y, plus the Z on top. That's the parameter. So now what we can see is that the value of this 2x plus 2y plus z, we know is exactly 2 times of the previous line, 2 times of 17. So this is equals to 30 plus 34. That's going to be equals to 64. That's the answer. Okay, let's move on to the next question. Question number 19. Arjun walks around a circular track at constant speed while Brian runs at 7 times of Arjun's speed. Both start moving from the same point at the same time in opposite directions. How many times will Brian have met Arjun after Arjun starts moving and completes one lap? Assume that both of them will maintain the speeds. Okay, so the idea is that Brian runs 7 times Arjun's speed. So if Arjun starts moving and completes one lap, the idea is that Brian completes 7 laps. Okay. Now, if I try to draw it out, we can split the circle like this into 8 parts actually, so that you can see what's going on. Okay, when let's say A moves to the right, B moves to the left, where is the first time they'll meet? Well, the first time they'll meet is here. This is the first meeting point. Because of the fact that you can see Arjun just goes this little part here. Meanwhile, Brian goes around the entire thing, like that, 7 times. So therefore, that will be their first meeting point. Now, same thing. From the first meeting point, where is the second meeting point? If you go and figure out, you can see that this line over here will be the second meeting point. Because once again, Arjun moves this little part here, and Brian goes around, right, 7 over 8 times of the circle. So from there, you can continue on. You can see that this part here will be the third meeting point. This part here will be the fourth meeting point, right? Fifth, sixth, seventh, and finally, when Arjun comes back to the start, he completes one lap, and that will be the eighth meeting point. So the answer is 8. Now, question number 20, we are presented with a pattern question. Now, this pattern question is a little bit different from most pattern questions you've seen. This one is more like a general IQ kind of question. Now, the way we can understand this pattern is that we are looking from the bottom to the top. So these two will affect this shape here. These two will affect this shape. These two will affect this one. These two will affect this. These two will affect this. And then these two will affect this. Now, how does the pattern combine? The idea is that it takes the part that is in one of the circles at the bottom, but not both. Okay, let me write that down. Each circle above takes one of the uh, takes the lines belonging to one of the circles below, but not both. Okay. Sounds a bit confusing, right? Let me explain and then you can understand. Huh? For example, let me use this one here. We can see that this line is present in both of the circles below. When a line is present in both of the circles below, it does not take it. We can see that this line belongs to only one circle, so therefore it is there in the final answer. This line belongs to only one circle, so it's there. These and these are only present in the circle on the left, so they are both there in the answer. This one, as well as the dot, they only belong to the second circle. So that's why this one, and a dot only will show up in the answer. Okay. If you're still confused, let me show you another diagram. Let me show with with this group. This one belongs to both circles, so it's not there. This one belongs only to the first circle, so yes, it's there in the answer. This line belongs to both circles, so it is not there in the circle above. And you can see that the dot belongs to both of the circles, so the dot is also not there in the above circle. And finally, the horizontal line over here is the only one that belongs to the second circle, so therefore the horizontal line is there. So this is why. Okay, let's figure out the final answer for this question. For the final answer, this line is in both of them, so it is removed. This part is only in the first circle, so let's draw it. Both of these are in the second, are in both circles, so they will be removed. This one here belongs to only the second circle, so it will show up as well. Okay. And then finally, the last one here is equals to this one, and it belongs to both of the circles, so it will not show up. So that's it. That's the final answer. Okay, so the answer is this 304 here. Now, interestingly, there's an application of this in computer science. If any of you are planning to take that in the future, this thing is also known as an exclusive OR operation. If any of you are interested what the meaning of exclusive OR is, you can go and Google it yourself and try to read more about it. Huh? But I'll move on to the next question. Okay, now we move on to question 21 onwards. These are the 3-point questions. Question number 21 says, at a charity fair, there were two kinds of notebooks sold, with one kind of notebook selling for $4 and the other kind selling for $5. And somehow in the end, you get $231. So you want to have 4A plus 5B is equals to 231. And then we're asking, how many different combinations can we get from here? Now, let's do a little bit of guess and check. Can A be 0? A cannot be 0, right? Because if A is 0, the problem that happens is that 5B is 231. That's not possible. Can A be 1? If A is 1, then 5B is equals to 227. Cannot. Can A be 2? If A is 2, then it's going to be 223. Cannot. Can A be 4? It's going to be equals to 219. No, wait, sorry, this is A equals 3. What am I thinking? This is A equals 3, sorry. A equals 3 will give you 219 for 5B. And finally, A equals to 4 will give you 215 for B. So the first value that works is A equals to 4 and B equals to what? B equals to 43, right? Because 215 divided by 5 is 43. Okay, I see a person making a lot of messages in the comments called CT Gaming. Yeah, we are all there here. Yeah. Okay, so let me continue. After we get 4 and 43, how can we get the rest of the numbers? Well, we need to still make sure the same thing that 231 minus 4 is a multiple of 5. And the only way you can keep it as a multiple of 5 is when you 5 to A. If you add 5 to A, you can keep a multiple of 5 for B. And then correspondingly, B will have to do what? B will have to minus 4. Because you have increased by a 4 times 5, you have increased by a 20 here. So same thing, you must decrease by a 20 over here. Right? So then the next number I can get will be 9 at 39. And at this point, you can probably see where we are going with this. 14, 35, 19, 31, so on and so forth. Now the question becomes, when do we stop? We stop when B goes to 0, right? So 20, 31, 27, 23, 19, 15, 11, 7, and then 3. And that's it. 3 is the last one. 3 is the last one because after that, B will become 0. That's not possible, right? How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So therefore, there are 11 possible combinations. Finish. Okay, let's move on to question number 22. Question 22 says, in the quadrilateral ABCD shown below, the diagonals AC and BD will intersect at E. It is given that AB is equals to AC is equals to AD, and then angle ADB is 41 degrees. Then they somehow want you to use this condition to find angle BCD. How to do that? Well, firstly, we start with the condition that this is a isosceles triangle. From the fact that this is an isosceles triangle, I know the other two angles here. I know that one of them must equals to 41 degrees, right? And then the angle at A is 180 minus 41 minus 41. This one here will be equals to 98 degrees. Now, actually, we are already done. I might wondering, huh? How do you get done from this? Well, because of this fact, from the isosceles condition, these two right angles are the same. I'm going to call both of them x. Take note the x is not 41 because the 41 is referring to angle ABD. Then same thing, we have another isosceles triangle, so I'm going to call this y. I'm going to call this angle y as well. Then for the entire quadrilateral, what you can see is that the sum of degrees of the quadrilateral is 360. So when we have this sum of degrees, we have x plus the angle at C. Angle BCD is x plus y, right? So it's an x plus y. And then we have the angle at D, which is the angle y. And finally, the 98 degrees at the top. Together, these four angles will be 360. So this angle, this angle, this angle, this angle add up to 360 degrees. So we just need to subtract 98 and then divide by 2. 2x plus 2y is equals to 262 degrees. Divide by 2x plus y is 131. Finish. Okay, let's move on to question number 23. We have two people, Lina and Royce, have a total of 400 pencils. First, Lina gives 60% of her pencils to Royce. Then, based on the total number of pencils Royce had after receiving, he gave 25% of that back. In the end, Lina had 127 pencils. How many pencils did Royce have at first? Notice that they are only passing pencils within themselves, right? So at the start, I don't really know what that is. After one pass, I still don't know, but at the end, I know that it must be 127 and 400 minus 127, which is 273. Look. So here I noticed that Royce gave 25% at the end. We'll work backwards. What must this number have been? Because he gave 25% to Lina, he keeps 3 over 4. So this one, do the opposite times 4 over 3, I can get back to Roy's number. If I divide by 3, I get 91. 91 times 4 is 364. Okay, so before the last step is going to be 36 and 364. But let's go and find the initial amount. Lina gave 60% of her pencils to Royce. So then this part here is only 40%, which is 2 over 5, right? To figure out how much Lina has at first, you take this number times 5 over 2, right? To work backwards. And then we have 18 times 5, that's equals to 90. So initially, Lina has 90, Royce has 310. That is the answer. Okay, question number 24. Three numbers ABC such that the ratio A plus B to B plus C to A plus C is 8 to 13 to 15. If the sum of the three numbers is 9, find the value of C. How to do? Well, here this question is almost entirely algebra. A plus B is 8 units. B plus C is 13 units. And then A plus C is 15 units. We can try to add all them together. If we try to add all of them together, we can get 2A, 2B, and 2C. That's 8 plus 13 plus 15. That's equals to 36 units. So A plus B plus C is 18 units. And this is 9. Now, how can we try to find C? Well, if I combine this and this together, I can subtract them. Okay, I see one of you asking how long is this video? This is not a video, this is a stream. We'll finish whenever I finish question number 35. Okay, so 18 units minus 8 units is equals to 10 units. So C is 10 units. Right. If 18 units is equals to 9, what's 10 units? Well, we can divide by 9 here. This is 2 units equals to 1. So 10 units will be equals to 5. That's the answer. Next question, number 25. In the first hour of a children's art exhibition, there were 155 children. In the second hour, 20% of them left, and then the number of girls increased by 30%. Thereafter, there were 159 children. How many boys were at the exhibition in the first hour? Again, this is very similar to a question we have already done, right? So, in fact, which question was it? It's the question with the oranges and the apples, right? If you know. So here, let's call the boys and girls B and G. B and G initially 155. Then 20% of the boys left, so it's 0.8 boys left. 30% of the girls came in, so it's 1.3 times of girls. This is 159. So again, we're trying to do the same thing where I try to remove either B or G. So here I notice one way to remove B is I multiply this one by 4, I multiply this one by 5, then I have the same number of B. 4B plus 4G, if I multiply by 4, this is equals to 620. If I multiply by 5, I can get 4B as well. 1.3 times 5 is 6.5. This is 159 times 5. That's equals to 795. So 2.5G is equals to 175. G will be equals to 175 divided by 5 times 2. That's how to divide by 2.5. So this equals to 70 here. And since we already know G is 70, finally we know the number of boys at exhibition in the first hour would then be 85. Okay, last 10 questions. All right, last 10 questions before we end. Now we are getting to the hard questions territory, the really hard ones. challenging ones. In the trapezium ABCD, we have AD parallel to BC. The base BC is 20 cm, and then we have a bunch of 60-degree angles. Right, so this is 60-degree, this is 60-degree. Then two equilateral triangles where the sum of the bases equals to AD are cut out. Find the perimeter of the remaining figure. Now, this question is both challenging and easy at the same time because you don't need to do any calculation in this question. You just need to realize cut and paste. How to cut and paste? Well, let's extend BA all the way upwards. Let's extend CD all the way upwards. So then cut and paste will be like this. I'm gonna draw out this line here. Hopefully you're able to see that firstly, this red line will be equals to this red line. And then hopefully you can realize that, let's say I color this green color, same as this green color, right? And then on the right side, this one here will go here. And then the line here will go here, right? But we can do this one more time. We can further bring the red one out again. So I bring the red one out already. I can further bring the red one out again to over here. I brought the brown color one out. I can bring the brown color one out again. So it's over here. So the result is that this thing will have the same perimeter as just an equilateral triangle itself with the base being 20. So therefore the answer is 60. Same. Finish. Right. Okay, let's continue. Question number 27. We have three different whole numbers add up to 182 and multiply to 74,088. Wow, that's a very big number, right? Then I say one of the numbers when squared is equals to the result of multiplying the other two. Okay, so let's say that I call them A, B, C. One of the numbers when squared is equals to multiplying the other two. So let's say we call A squared equals to B times C. Right? Then how? Well, here there's an interesting thing we need to do. We need to try to factorize 74,088. Okay, let's try to do that. One thing I immediately notice is that this number is a multiple of 8. So if I try to factorize, yes, I can take 2, I can take 2, and I can take 2 again, but it's simpler to just take out 8 at the same time. Now, if you take out 8, what happens to 74,000? If I divide by 8 here, I can remove 72, and then 2,000 divided by 8 will give you 250. Then this 88 will give you 11, so this is 9261. Okay, so this is how you factorize. Now the number is no longer even, the number is odd, so 2 doesn't work anymore. Let's try to do with 3. This number is a multiple of 3, right? Because the sum of digits is a multiple of 3. In fact, not just that, the sum of digits is a multiple of 9. So let's take out a multiple of 9 here. If I divide by 9, it'll be 1,029. Let me just check my workings. 1,029. Yeah, that's correct. 1,029. Which is still a multiple of 3. Let's factorize the 3 out further. If I take out a 3, this will be equals to 343. Which is actually what? Which is actually 7 times 7 times 7, 7 cubed. So then this number that we actually have here, we know roughly what it's looking like, right? We know that it looks like the number 2 cube, which is from the 8, 3 cube, which is from the 27, from the 9 times 3, and then it has a 7 cube from the 7 cube, obviously. Okay? So this is the number here. Okay, so like that, how do I figure out what the numbers are? The idea is that we know exactly what A is. We know that A itself, this guy A must be 2 times 3 times 7. Why A must be 2 times 3 times 7? Because the remaining two numbers if you if you do them, b times c is equals to a squared. So actually, what we can notice is that a times b times c is just going to be a times a squared, which is a cubed. So a cubed is the 2 cube times 3 cube times 7 cube, right? So that's the reason why a is actually 2 times 3 times 7. A will be 42. Now the remaining two numbers, what happens? The remaining two numbers, they multiply to give you 2 squared times 3 squared times 7 squared. And their sum is equals to 182 minus 40. Their sum is 140. So what are the two numbers? Well, if you're this one, you need to use a little bit of guess and check. If you use a little bit of guess and check, you'll be able to figure out the two numbers here are actually I haven't checked this yet. Let me try. Divide by 2, 70, 70, wait, 49, 9, hmm, wait, somehow I cannot find which are the two numbers here, which is a bit funny. Okay, they are both going to be multiples of 2. I know that for a fact. So that I can get even number. And then, oh, okay, I get it. It's 2 times 7 and 2 times 63, right? Yeah. 2 times 7 and 2 times 63 together, they add up to 140. So here you have to use a little bit of guessing. So you try for a while, and then that's how you can get the numbers. Right? 14 and 2 times 63 is 126. So therefore, the smallest number in this case is going to be 14. That's it. That's the answer. Okay, question number 28. Clarence wrote down 6 different numbers on each side of 3 cards, and 2 of the numbers are as shown. The sum of 2 numbers on each card are equal. Then you have 3 numbers A, B, C are prime numbers, and E is a number, even number between the other 2 shown numbers. What's the sum of all possible values of A? So what we can see here in this case is that we have a sum equals to a sum equals to another sum. And then A, B, C each are going to be primes. And E is even. Okay. Now, let me see. We know a little bit about the number E. E is going to be 38, 40, 42, 44, or 46. Right. So one of the questions we can ask ourselves is that, is it possible that this sum equals to this sum equals to this sum? Now, most prime numbers will be odd, right? Most prime numbers will be odd. In that case, even plus odd number is odd. Odd plus odd is even. Even plus odd is odd. So if somehow they are not equal to each other, then how? If they are not equal to each other, then there's something that's wrong here. That means one of the prime numbers is actually not an odd number. One of the prime numbers is actually going to be an even number for this to work. In that case, what's the only even prime number? The only even prime number is 2. The only even prime is equals to 2. Okay. The only even prime is equals to 2. Then what you can see is that one of them must be a 2. So it must be 47 plus 2, for example. Now, 2 doesn't have to be B. 2 can also be A and 2 can also be C. We need to think of that. So 47 plus 2 is 49. And immediately we can figure out one of the other pairs, which is 36 plus 13. Because 49 is 36 plus 13. Now let's try. 49 is also going to be 38 plus 15. Sorry. 38 plus 11. Is 11 a prime? Yeah. It's going to be 40 plus 9. Is 9 a prime? No. It's going to be 42 plus 7. Is 7 a prime? Yes. It's going to be 44 plus 5 is 5 prime, yes. It's going to be 46 plus 3 is 3 prime, yes. And then that's the values that we have. So therefore, these numbers here, what can they be? One of them must be a 2, one of them must be a 13, one of them can be a 3, 5, 7, or 11. So therefore, these are the 6 possible values of A. The sum? The sum is exactly equals to, let me check, 10 plus 20 plus 11, 41. So the sum of all possible values is 41. Okay. Here I'm going to pause for 1 minute because I realize that my computer is running out of battery. I'm going to find the charger for it. Just give me 60 seconds and I'll be back. Okay, I'm back. Okay, let's continue on with question number 29. So question number 29, what does it say? Question number 29 says that there are 66 students in the school orchestra, among whom 60 can play piano, 58 can play violin, 55 can play flute, and 50 can play the trumpet. It is known that key students can play all four of these, all these four. Find the minimum value of K. I want to minimize the people that can play all four. If I want to minimize the people that can play all four, I want to maximize those that cannot play something. From the questions, I know that 6 cannot play the piano. I know that 8 of them cannot play the violin, right? Because it comes from 66 minus 58. I know that 11 of them cannot play the flute. And finally, 66 minus 50 is 16. 16 of them cannot play the trumpet. So what we can do here is that we can just simply add them up together. Because what this tells you is that at most, 6 plus 8 plus 16 plus 11 is 41 students. They cannot play something. At most, 41 students cannot play something. What does that mean? It means that at least 25 students can play everything. That's it, right? You have 6 people who cannot this, 8 people who cannot this, 11 people who cannot this, and 16 people who cannot this. So at most 41 people cannot do something. At least 25 people can do everything. Okay, question number 30. Question number 30, we have a very long looking word problem. What does it say? It says that a health center with capacity of 300 will have 10 senior doctors, 20 junior doctors. Each senior can look after 25. Each junior can look after 20. In any 7 days, the senior doctor needs to take 2 days rest. So this is 5 working days, 2 resting days. Each junior doctor needs at least 1 day rest. So that's 6 working days, 1 resting day. During the pandemic, the health center expanded to receive 800 people now and it always operates in full capacity. Hence, they need another X senior doctors and Y junior doctors. Okay, how to do that? So the idea is that we try to figure out uh, the doctors, the senior doctor and the junior doctor, which one of them is more worth it, right? To use to look after the patients. So senior doctor can look after 25 patients every day, but senior doctor is only here uh 5 over 7 all the time. So senior doctors, the effective rate of it is going to be 25 times 5/7, right? Each effective rate of a senior doctor is this much. For a junior doctor, it's going to be what? It's going to be 20 times 6/7, right? Because junior doctor takes 1 day of rest. So senior doctor can care for, on average, 125/7 per day. Then junior doctor can care for, on average, 120/7 per day. Now, of course, you cannot care for half a patient, right? Or like 1/7 of a patient. But this is an average, so this is acceptable. This is an average across the entire week. So who is more worth it to hire? You can see that the senior one is more worth it to hire, right? Senior is more worth. Wait, I forgot the word more. So in the end, what do you need to do? If you're hiring doctors, you're not going to hire any junior doctors anymore because you don't want the junior doctors to go and replace them. You want to hire senior doctors whenever possible. So in the end, you're going to get 10 plus X senior doctors, and you're just going to get 20 junior doctors. Okay? So this must cover for the 800 patients. So how much must it be? Well, we know that this must be 10 plus X times 125/7. And then the 20 junior doctors will be 20 times 120/7. And this must be exactly the 800 patients. Or rather, it must be at least 800 patients, right? Because it needs to cover for them. Okay? So let's figure out what this is. We can do that by multiplying by 7. So we have 10 plus X times 125 plus 20 times 120 is equals to, is at least 5,600, right? Now, if I subtract 20 times 120, that's 2,400 from 5,600, I can get 3,200. So 125 times of 10 plus X is at least 3,200. So now I can divide by 125. Unfortunately here, this number is not exactly a multiple of 125, right? But that's still okay. This one here, if you divide here, we'll get some value that is 81 point something. If it's 81 point something, then how many doctors do you need to hire? X must be at least 72 for this to be a whole number. So that's it. The answer for this question is 72. All right, 72 senior doctors and then 0 junior doctors. Wait a minute. Let me just check the answer again. Uh, wait. 10 plus X senior doctors 125/7. Just give me a moment. I'm just checking because this doesn't seem to make much sense. Because senior doctor can definitely look more than. Wait, I feel like I made a mistake here somewhere. Give me a while. 125/7. Oh, no, no, it's not 81 point something. I did the calculation wrong. Wait. Up to this step is still correct, but I divided wrongly. This is not 81 point something. This is 25 point something. I don't know how I calculated 81 point something. This is 25 point something. Sorry about that. Yeah. So, okay, let me just check through my calculation again. Let me just make sure that I have the correct calculation. This is 2. This is 700. 700 divided. This is 5, right? Then this is 625. Yeah. So it's going to be 25 point something. So X must be at least 16 actually. Sorry about that. Okay, finally, we move on to the final 5 questions. Question number 31, find the perimeter of the figure shown. The idea is to make it an equilateral triangle. Because what we can do is that we can draw in this part and this part, which will be the same perimeter. And now what we can do from there is that we can extend to form a equilateral triangle. Okay. So for these equilateral triangles, I know a few things. I know that the 7 cm on the bottom left tells you that this is 7 and this is 7. I know the 2 cm of AB tells you that this is 2. I know that the 3 cm is just 3, and then I know the 4 is on the right. So then, how do I find out the length of each of them? Well, actually, I drew the wrong equilateral triangle. Sorry about that. Wait a minute. This is the wrong one. The correct equilateral triangle to draw is the other one. Is this one. Now, you might be wondering what's the difference. The difference is because by drawing this equilateral triangle, I actually know the exact side lengths of the equilateral triangle. So this is 2. Let me erase this. This is 2, this is 2, this is 3, this is 3, this is 4, this is 4. Yeah. So now this is equals to 2 plus 3 plus 7, this is 12. So this is also 2 plus, this is also 12. So then we have a 6 here, right? We have a 6. And then on the right side is also 12, so this is a 5. Yeah, correct. So therefore, the sides of the hexagon, they will be 7, 3, 5, 4, 6, and 2. The final answer for this question is going to be 27. Okay, question number 32. We have the Sierpinski's triangle. It's a fractal. As for what a fractal means, you can go and search online if you're curious. It consists of an equilateral triangle, and then you create smaller equilateral triangles by removing its remaining area as well. So then they do it in the following way. Then you want to find the number of black and white triangles in the stage 7, and then find B minus W. So let's go and do stage 0, 1, 2, 3, 4, 5, 6, 7. 0, stage 0, 1, 2, 3, 4, 5, 6, 7. Black and white. Stage 0 is just 1 black, 0 white, right? Stage 1, you can go count directly, is 3 black and 1 white. Stage 2, you can also go count directly, is 9 black and 4 white. At this point, you probably can notice a pattern about the number of black. It's always going to be times 3 each time. It's always times 3 because each time you split up a triangle into 3 smaller black triangles. So it's always a times 3, so it's going to be a 27, 81, 243, 729, and then finally times 3 again, 2187. What about the number of white? The number of white is actually going to be adding up the number of blacks together. Here you have a 1 and a 3, they give you a 4. Next step, if you notice, if you go and count, the number of white is actually 13. It's because you have the existing 4 triangles, and then you add on the new 9 white triangles you create in the previous step. So stage 3, if you're going to count, there's actually going to be 13 white triangles. The 4 from the stage 2 plus 9 of them. Next one, 13 plus 27. Next one, 40 plus 81. Next one, 121 plus 243, which is 364. You might even notice a pattern here, right? You might almost notice this pattern that at each stage, the black is always going to be 2 times white plus 1. Wait, let me just write down somewhere. At each stage, this is correct, right? So at the last step, you can either just take 2187 minus 1 divided by 2, Or you can do 729 plus 364. Either one should give you the answer of 1093. Therefore, when you have 2187 minus 1093, the final answer for this question is 1094. Okay, question number 33 here. Now, the last 2 questions, they are all going to be pretty tedious. Just a fair warning. Right. Question number 33. This question here asks for how many rectangles do not contain the black square. So the way we're going to do this question is that we are going to count how many rectangles are there here. Minus those that contain the black square. And then we add those numbers that uses one of these in the top rows. Uses one of these 4. Okay, let me explain firstly why does this work. The reason why this works is because the black rectangles can only be formed within here. There's no black rectangle that will use one of 1, 2, 3, and 4, right? So any rectangle that uses one of 1, 2, 3, and 4 is automatically not containing the black square. So that is the thing we'll be adding at the end. Then now within here, the way to find how many do not contain the black square is to use the total number minus away those that contain the black square. Okay. How many rectangles are there here? The answer, 100. Why are there 100 rectangles here? Is because each rectangle it has a top and a bottom. Now there are 5 lines for a top. Oh, sorry, this is not 100. Sorry. I just realized I drew an extra line. Sorry about that. Sorry. Okay, so for the first one here, each rectangle has a top and a bottom. So there's going to be 5 lines to choose from a top and bottom. You need to choose one top and one bottom. There will be 2 things you need to choose. 5 choose 2 for this part on the left. Then there are 4 vertical lines. So you need to choose a left and a right side. This will be 4 choose 2. This means that there are going to be 5 choose 2 is 10, 4 choose 2 is 6. There's going to be 60 rectangles here. How many of those contain the black square? If you contain the black square, your left side must be one of these 2 lines to contain the black square. The right side must be one of these 2. The side on top must be one of these 3. And then the side at the bottom must be one of these 2. So the number of ways to contain the black square is 2 times 2 times 3 times 2. This is equals to 24. So I need to subtract off 24. And finally, we add back those that contains one of these. How to count? How many contains either these or these? Let's just figure out the top row first. You can have 1 or 1. You can have this one or this one, right? You can have this. You can have this. You can have this of length 4. You can have this of length 4. And then finally, you can have the entire thing of length 5 that contains both of them. So there will be 9 rectangles containing either rectangle 1, square 1 or square 2, right? There'll be 9 of them. So if there are 9 of them here, actually the answer is that there are 27 in this case. Why 27? Because there's 9 of them that uses the first row, right? As shown here, there's 9 of them that uses the first row. There's 9 of them that uses the second row. And then finally, there's 9 of them that uses both rows. So therefore, 9 plus 9 plus 9 is 27. Together, the answer for this question is 63. Finish. Now, of course, you can choose to not do this. You can go and count the number of rectangles directly. You can do that as well. But if you count the number of rectangles directly, the chance is that you might make a mistake somewhere. And then if you don't realize you made a mistake, then you might get the wrong answer. Okay, question number 34. Question number 34, we have the nth triangular number is the sum of the first n natural numbers, and a pattern is formed by arranging consecutive numbers like this. And a pattern continues with each new triangle having one more row than the previous one. What's the first four-digit number in the bottom row that starts with 2? The idea behind this question is that it uses something called tetrahedral numbers. What do I mean by tetrahedral numbers? We know what triangular numbers are, right? Triangular numbers are 1, 3, 6, 10, 15, 21, and so on. Tetrahedral numbers will be, you do 1, 1 plus 3, 1 plus 3 plus 6, 1 plus 3 plus 6 plus 10, 1 plus 3 plus 6 plus 10 plus 15, and so on. These are called tetrahedral numbers. 1, 4, 10, 20, 35. Tetrahedral numbers are the numbers that are on the bottom right corner of each of the triangle. That's why we are interested in tetrahedral numbers. Now, another fact about triangular numbers is that triangular numbers is going to be 2 choose 2, 3 choose 2. This is going to be 4 choose 2, 5 choose 2, and 6 choose 2. In fact, for tetrahedral numbers, it's something similar. This is going to be 3 choose 3, 4 choose 3, 5 choose 3, 6 choose 3, 7 choose 3, and dot 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 dot. Okay? So in the case, we want to actually achieve a number that is above 2000 using something choose 3. Now, if you try for a while, you realize this fact. So try for a while. I will not show you all the steps in between. You can get 24 choose 3 is equals to 2024. You can trust me on this, okay? 24 times 23 times 22, divide by 1, divide by 2, divide by 3 is 2024. So that means at some point, there will be a triangle. There will be a triangle where the bottom right number is a 2024. So will this be the first four-digit number that starts with 2? Well, maybe not, right? We have to figure out how many numbers are in this column. This is going to be a 3 choose 3. This is going to be a 4 choose 3, a 5 choose 3, and so on, 6 choose 3, and a 7 choose 3. If you notice the pattern, the number of numbers in the column is going to be this number minus 2. Here there are 4 numbers. There's going to be 6 minus 2, right? Here there are 3 numbers. It's going to be 5 minus 2. This is 4 minus 2. This is 3 minus 2. So to go from here to here, we do a minus 5, which is 7 minus 2. What does it mean? It means that from here to here is a minus 22. It is a minus 22 because 22 is 24 minus 2. So this is 2002. And then the previous one will be a minus 21. So that's going to be 1981. That's too small. So therefore, the first four-digit number in the bottom row is the number 2002. Finish. Okay. Finally, the last question of this thing, we have a logic question. We have 5 soccer teams A, B, C, D, E participate in a round robin tournament. The winner gains 3 points, the loser gets 0, and if both teams draw, then they each get 1. The total score of all the teams is 24, and they are all going to be mutually distinct. So what does that mean? Mutually distinct just means they are all different. If they're all different, what is the one possibility for 24? 24, I noticed that it could be, okay, if I have 25, it's 76543, right? If I have 76543 is 25, then 7654 and 2 can give you 24. This is a possibility. Now, is there any other possibility? Yeah, there can be more. For example, I can do 86541, right? I can do other numbers. I can do, for example, 874, no, sorry, 87531, for example. You can see that there are many, many ways for me to get 24. So there are many ways here, but the way that I want is which one? The question asks, A is the first team that scores X points, and then the last place team scores Y points. I want to minimize X squared plus Y squared. That means that I want to make X small. And I want to make at the same time Y big. If I make x small and make y big, then x squared minus y squared is as small as possible. So I want to make A small. And I want to make the bottom team, let's say it's E, as big as possible. In that case, which is the best choice? The best choice is 7 and 2. Right? Now I might think, okay, what happens? Why not maybe they can get close to each other? Why not, let's say 7 and 3? Is that possible? No, because they're all different, right? If it's 7 and 3, it must be 7, 6, 5, 4, 3, and that adds up to 25. We know that it's not possible. Right? So the closest that they can be is just a 7 and a 2. Let's try to verify whether it's possible. But the answer should be this already. The answer should be 7 squared minus 2 squared, which is 45. But let's just check that this is possible. So there is a way that they can score 7, 6, 5, 4, and 2. You let B be the one that defeats A. You let A defeat E and C and draw with D. So like that, A will have 7 points, right? From losing once, winning 2 times, drawing once. A has 7 points. B wins once. So B draws with E, draws with D, draws with C. B has 6 points. Right. And then C, you can win E, draw with D like that. You can have 5 points for C. Then like that, D can have 4 points and E can have 2 points. So indeed, 7, 6, 5, 4, 2 is possible. So therefore, 45 is the correct answer. Okay, with that, we come to the end. I noticed some of you say that, oh, I'm cooked. Oh, I'm very cooked. You don't have to feel that way because for a math competition, it's meant to be very difficult. In fact, if you participate in a math competition, if you can pass, that's considered a very good achievement already. Because most students who take this, they cannot get above a passing score at all. So don't worry if you're not able to do any of, let's say, the last 5 questions. All right, because the last 5 questions are meant to be very difficult. Uh, in fact, if you are not able to do most of 21 to 30 is okay as well. If you do maybe 1, 2, or 3 questions from there, it's fine. That's a pretty good result itself. Just make sure you get the starting few questions correct, and then maybe the middle section you try to do as much as you can. Okay, that's about it for today. Yeah, it's been quite a long stream. Thanks for checking in. If you have any questions, I'll stay back and answer. Otherwise, that's it for today. Yeah, bye bye. You got more than 21. Very nice. 21 is how many? Um, it's like 10, maybe 15 questions, 16 questions. If any of you want me to explain maybe one question one more time, I can do so as well. Okay, I see no one else suggesting anything, so I will stop the stream here. Bye bye.